So just to repeat, the recording has started. We have prepared some presentations and some introductions, and then after that you will all be able to ask questions. We're a relatively small group, so I hope we can be as interactive as possible. Please do not hesitate to raise your hand if you would like to say something, if you have an immediate comment or a question. I think we can always accommodate that. And with this, I would like to give the word to Simonetta Cheli. Welcome.
Good afternoon, dear colleagues from the FAIRS. Thank you, Nina. Also, hello to my colleagues from ESA and JAXA in Vandenberg here in Europe. We're very happy to be here today with you for this press briefing about EarthCARE. The mission is coming up soon, and it's a mission which is really relevant to look at the climate challenges that we currently have. In fact, if we go to the first slide, Earth observation is really supporting these days all what is about our Earth, all the climate challenges, the tipping points that we all hear about, and we use Earth observation data, satellites and mission more and more to better observe, understand and manage our planet Earth. This mission, EarthCARE, is part of this sets of satellites that ESA has been developing exactly to have some permanent objectives in terms of science objectives, and meeting those objectives can certainly contribute to climate change. As you've seen, last year was the warmest ever recorded year in terms of temperatures, and this mission will really help also in looking at the way the Earth radiation budget is being managed and it's been organized, which means is also associated to raising of temperatures. If we go to the next slide, we see what is the overall context of the program that ESA is currently managing in terms of Earth observation mission. It's missions that span from meteorological mission. We started to develop those with EUMETSAT in the 70s, and today we have launched a year and a half ago the Meteosat third generation. We're ready to launch next satellite, the Arctic weather satellites, very soon in early July. We have also the series of missions which are more operational ones of the Copernicus program, which is led by the European Union, co-funded with ESA, with the Sentinel missions, a lot of those already up and running and many coming up. And last but not least, of course, the Earth Explorers, and that's what EarthCARE is about. Those are science missions. They're missions that have a primary science objective. They're one-off, so they're not in a series, but they're missions that have already given, in many cases, the basis for preparing for future operational missions. So today we have 14 satellites in operation in Earth observation, 39 in development with the European space industry, and the Earth observation budget represents in 2024 30% of the overall ESA budget. So the biggest, I would say, area of investment currently for ESA. If we go to the next slide, we see about the Earth Explorers, what they're all about. Earth Explorer 6, which is EarthCARE, is the sixth one, as is said here, after many already launched and very successfully launched. GOCE, which ended already its lifetime, which looked at the gravity of Earth. Cryosat at the ice thickness, and then we have SMOS on soil moisture and ocean salinity, and SWARM on the magnetic field, and then EOLUS, which has looked at the wind profiles and has also prepared for future operational mission EOLUS 2 that we are currently developing. So today we are here with EarthCARE, but coming up next and very soon, biomass on the canopy of the forest, and Flexon Forum and Harmony mission for the late 20s. So you see a series of science missions which are incredibly relevant for understanding better our Earth and everything that's related to climate. Then if we go to the next slide, we see an animation of EarthCARE. You'll hear all about the experts, and they will tell you what this mission is about. But basically, EarthCARE is a mission that was conceived about 2 decades ago, but it's still, as I said, very relevant because it will look at the radiation budget, which is basically the radiation of the sun towards the Earth and the way that the cooling effect is done by clouds, aerosols and precipitation. And we will learn much more about cloud, aerosols and precipitation thanks to this important mission. It's a mission that is done with JAXA, so it's a very important mission also in terms of partnership with the Japanese Space Agency. You will hear about the contribution of JAXA to this mission. It's the cloud profiling radar, one of the 4 instruments which is on board this mission. So we'll see better how the budgets related to aerosols is regulating the Earth temperature, and we'll learn all about it also from the colleagues from Airbus, who have been the prime contractorship, who have developed this mission with over 70 industries in Europe, and prime contractor Airbus Defence and Space in Germany. So you see here some of the critical questions. I won't dwell into the 4 instruments, but basically we have on top of the cloud profiling radar, which is the in-kind provision by JAXA, we have an atmospheric LiDAR on board. This is going to provide cloud top information. We have a multispectral imager, and we have a radiometer on board. And all of these will contribute to better understand also numerical weather prediction as well as climate models. In fact, we have partner agencies like the ECMWF, which is really looking forward to use at best data from this mission.
Thank you very much.
Least, the international cooperation dimension, I already mentioned it. ESA's 22 member states, all the ESA member states contribute to FutureEO, this important framework program to which EarthCARE belongs. It was developed with the project team in the Netherlands. You have here the project manager in Germany with the prime contractorship of Airbus, but also with Italy having the exploitation of those data in Frascati with the Mission Management Office, and of course JAXA in Japan. So thanks a lot, and looking forward to the launch next week and to see you all following that closely.
Thank you very much, Simonetta, and you already mentioned very prominently JAXA, and it is with great pleasure that I would like to give the word to Mr. Takiguchi, who is the Vice President and Director General for the Space Technology Directorate at JAXA. You will need to turn on your camera and your microphone again because we are recording, so then you will be able to speak. Thank you. The word is for Mr. Takiguchi. We see you very well.
Can you hear me?
Yes, we hear you very well as well. Welcome.
Oh, thank you for your introduction, Ms. Manning-san. I'm Futoshi Takiguchi, Vice President of JAXA, responsible for Earth observation, satellite development and operations, and satellite utilizing. The launch date of EarthCARE satellite is coming soon. I feel excitement. That all EarthCARE stakeholders, and since the growing express for the variable data to be acquired by this satellite. I'd like to express deep my gratitude for all stakeholders supported this mission. As for Earth observation, I concern about climate change and its effects. Climate change is not a future problem, and it is reality that we are facing right now. Climate change is a threat to our well-being, food security, even to national security. Most likely, this threat will be growing in the future. So JAXA has been developing and operating various Earth observation satellites since the first Earth observation launch in 1987. Those satellites have been witnessing climatic and environment changes for over 30 years. For example, this chart and graph shows the sea surface temperature trends variation during 2000 and 2024, observing by our advanced microwave scanning radiometer. Since March 2023, monthly global surface temperature is have been recorded highest value each month. And next slide shows the forest changing in Rondonia, Brazil, for over 2 decades. Is captured clearly by our L-band synthetic aperture radar, Aerosol. No doubt, there is no doubt Earth observation satellite is there is no doubt our Earth observation satellites are powerful tool in recording and archiving the status of changes in the future and present. Additionally, what is needed even more now is prediction. It is in order to for us to live safety in near and distant future. We have to need to know the climate change progress and take action to adapt to it. That's where the EarthCARE mission comes into place. To predict the future climate, I recognize numerical climate model is used, but natural phenomena and mechanisms related to climate still remain complex and mysterious. It is said that the biggest mystery is the effect caused by clouds and aerosols, which targets of the EarthCARE observation mission. I believe EarthCARE data contributes to advancement of climate model and their capability, prediction capability. Well, EarthCARE is the first joint mission between ESA and JAXA in Earth observation. For one of 4 sensors onboarded EarthCARE CPR cloud profiling radar was developed in Japan jointly JAXA and NICT. NICT is Japanese National Institute of Information and Communication Technologies. CPR is the world's first satellite-borne millimeter wave Doppler radar, measures upward and towards flow velocity within clouds. Not only EarthCARE, JAXA and ESA is cooperating in various development and research fields. So ESA is indispensable partner for JAXA. It is essential to cooperate internationally to achieve the goal beyond the effort of one region, one country, such as EarthCARE mission. Again, as climate change is a common issue for all lives on the planet. So its solution required to cooperate internationally beyond the border. It is easy to call international corporations, but there are accomplishing goals often should often go through the hardship. Particularly in the world, today's world, there are serious fragmentation and conflict. I hope so. I believe that EarthCARE. I believe that the Japan-Europe joint mission EarthCARE can be the hope that different regions can work together for a shared goal addressing global agenda. In the more than 20 years history of EarthCARE development, I guess there have been ups and downs. Those experiences have fostered a sense of unity and togetherness among those involved in this mission. So an excellent team has been built, and all team members are prepared for operation, prepared for EarthCARE operation on orbit. Now we are ready for launch. I hope mission success and good luck. Thank you for my attention.
Thank you very much. Thank you very much. With this, I would like to give the word to Dirk Bernaerts, who is the EarthCARE project manager and currently the acting head of the Earth Explorers division at ESA. Dirk, the floor is all yours.
Good afternoon, everyone. I hope you can see my presentation. I'm happy to be here together with Max Sauer, project manager from Airbus, and Tomita-san, project manager at the JAXA site here at Vandenberg, to prepare EarthCARE for launch. EarthCARE, we have seen already these slides. EarthCARE are there to study the effect of clouds and aerosols on basically the thermal balance of the Earth. Clouds give shadow, they cool the Earth, but on the other hand, they also act like a blanket. They keep warmth on the Earth, and that's why it's important to study it. Aerosols, they affect they also shield the the heat, but on the other hand, they are also very important for the formation of clouds. Aerosols and clouds are rapidly changing in time and in location. And that's why it's very important, and that's a crucial aspect of EarthCARE. It's very important to observe them all together at at the same location at the same time. And that's what we do and what is unique on this spacecraft. We have 4 instruments, all working and observing exactly the same position at the same moment on Earth. It's generating information related to the clouds in multiple ways. The radar, the cloud profiling radar from JAXA, studies the structure and the dynamics, the movement inside the clouds. That's what you see on the top left. At the same time, the athlete instrument, which is a LiDAR, a UV LiDAR, observes the outside of the clouds, the edge of the clouds, but also the thin atmosphere in between the clouds. So they are very complementary in what they observe. Then we have a multispectral imager that gives a context and also allows for 3D reconstruction of the data. That is what we call MSI, multispectral imager. It looks in visual, near infrared, and thermal infrared to the scenes. All this information that is gathered from those instruments is put into the mathematical models for climate and weather predictions. And they are compared. Basically, these models predict how much thermal energy is going back into space instead of staying on Earth. And we compare that with the 4th instrument, which is the radiometer, the broadband radiometer, that measures indeed how much thermal energy is radiated back into space. And with this, we can study very intricately the relationship between clouds and aerosols, and all for the benefit of improved models for weather forecast and climate modeling. The 4 instruments, you see the pictures here, they were quite technologically advanced. They were, as such, because they're groundbreaking technologies, they were quite a challenge to develop. But on the other hand, they have given ESA, industry, JAXA, unique capabilities that are leading edge still today. If we look to EarthCARE, it's more than just a satellite. We have operations. This is performed in ESOC in Germany. They are planning the mission. They are operating the mission. Then we have the processing of the data that is performed both in Europe, in ESRIN, but also in JAXA. And the data is then used by a number of agencies, a number of scientists, including, for instance, ECMWF. We have validation and calibration campaigns where EarthCARE will be underflown by aircraft or ground stations to calibrate and validate the data. And we have a large science user community that is very eager to have the data of EarthCARE. Where are we today? As mentioned, we are here in Vandenberg. You see on the top right of the pictures, you see the spacecraft on top of the launch vehicle adapter for the rocket, the Falcon 9 rocket. And today or tomorrow, the spacecraft will be encapsulated, as we call it, in the fairing of the rocket. So the spacecraft is basically fully ready to go. We have to remove the protective covers, but for the rest, the spacecraft is fully ready to go for launch. The flight control team is fully trained through a long campaign of simulations, and now we are doing the communication and preparing the science community. What happens on the day of the launch, which is not earlier than the 28th next week? Basically, in Central European time, at 3 o'clock in the afternoon, we start with all the activities to prepare spacecraft and the ground segment. Liftoff is at 20 past midnight. 10 minutes later, the spacecraft will be already released from the launcher And then we have a deployment of the solar array and first ground contact after that. The CPR reflector, so the cloud profiling radar reflector, will be deployed 1 day later. In summary, EarthCARE was the most complex Earth Explorer mission so far. It's a symbol of collaboration. Instruments are collaborating, organizations are collaborating, teams are collaborating, and it's thanks to this collaboration that we can do these unique science observations. It's challenging, but still fully relevant and very highly anticipated. And one of the quotes was stated by Professor Stier from the University of Oxford. He said, EarthCARE may have been delayed a little, but it could not be more timely. Not before May 28 is the launch, and then we expect to deliver the first products to the science community, and 24, beginning of 25. Finally, we're very happy that JAXA has basically requested to use a nickname. It's Hakuryu, which means white dragon, and the explanation of what you will see it in close to the launch event. You see probably more images and stickers like that. It has a very symbolic name. It is a dragon that flies fast through the clouds, symbolizing the mission. And it's also a symbol that could be related with your cooperation with the West, being Europe. So we're happy for that. And with this, I would like to give the floor to Max Sauer from Airbus.
Okay. Hello to all of you. My name is Maximilian Sauer, as you can read here. I'm the project manager from Airbus. Had the pleasure to lead at least half of the lifetime up to now from EarthCARE, this beautiful satellite project. I'm located in Friedrichshafen, so southern part of Germany. You can see here the satellite during its environmental testing. It was the EMC test. We did in ESTEC last year. EarthCARE is an undertaking, I can tell you. We have close to 50 subcontractors underneath our responsibility, spread it over 15 European countries. So basically all European countries were involved in developing the satellite. 7 Airbus sites. The main countries contributed to the spacecraft were Germany, France, where we built the most complex optical instrument ever built, which is the Atlas laser, and UK, where we procured the other 2 instruments, the MSI and the BBR, which are the optical instruments you saw before, and the base platform, so the bus basically, which carries all the other instruments, including the instrument from JAXA. More than 500 people were involved, even 1,000, I would say, and the 15 years development, I will say a little bit more to it in a second, are showing as well that this thing was not an easy task. Okay. So EarthCARE itself is a special satellite. You will never ever see something like that, I guess, in future. It's a very slim, very packed satellite, very dense. We never built something compressed like this. This has a reason. We are flying quite low. We are flying in a 400 kilometers sun-synchronous orbit, like the space station roughly. And if you look to the space station is as well white. We are flying so low since we need a certain distance to the clouds, and the distance is more or less defined by the distance the laser needs to collect the few photons which are reflected back from clouds if you look from the top of them. This low orbit has still a kind of drag against the satellite, so you need to avoid drag against this residual oxygen up there or residual atmosphere up there. So it's very slim. You have that long solar array underneath. You have a white colored MLI, not the golden shimmer colored MLI or protective cover around the satellite you may see when you look to others. This is as well be resistant against atomic oxygen. So this is why we look like this white dragon shown before. A very nice picture to illustrate how EarthCARE looks like. It will have a 3 years nominal lifetime. So we will not only build, we have not only built the satellite, we have not only developed it, we have tested it, as said last year, on system level. We will now be responsible to bring the satellite to launch. And then we will more and more hand over to the community, to ESA, to JAXA, to provide the data. These data will then be, bring the benefit, or EarthCARE will hopefully bring to society. Okay. It was a long journey, as said, as a glance. We did the kickoff in 2008. We are now in May 2024, so you can see a lot of colleagues have participated to this undertaking. We had a lot of obstacles to overcome. Clearly, after 15 years, there were COVID in between. There were the Ukraine crisis in between, which forced us to change the launcher very late. There were many technical issues we have to resolve, as said, to bring now a beautiful piece of hardware with cutting-edge technology still on board, to add to our one of the main residual questions all the climate models have in it. It was a pleasure and is still a pleasure for us industry to participate to such a beautiful project, to such a beautiful undertaking. I think Europe and as well with JAXA, somehow worldwide, we can be proud of having built something like this. And I'm 100% sure it will bring the benefit, all we hope to. I think that's it from my side. I then like to say thank you. This is the complete team you see from ESA and JAXA and Airbus during our environmental test campaign. You see the satellite in the back, quite small in a big TV chamber, was taken a year ago, basically. And now we are here. And the last week in front of us is really the final inch on that long journey, as said. Thank you again. Greetings from Vandenberg, and then looking forward to a successful launch next week.
And then the final presentation from Tomita-san, from Tomita Eiichi from Japan.
Hello, everybody. I am Eiichi Tomita, project manager of JAXA EarthCARE CPR project team. For EarthCARE mission, JAXA have provided the cloud profiling radar CPR, which is the first spaceborne cloud radar that can measure the velocity of upward downward flow. CPR tasks by JAXA and industry team have been completed by the beginning of May. It was a very long way, but we could reach here under the good collaboration with European Space Agency, including industries, both industries. JAXA team is ready for launch in here, Vandenberg. In Germany, JAXA team will be getting ready for launch this week, and also in Japan. I'm expecting how EarthCARE products will be. Everyone can use the all EarthCARE products from the both JAXA G portal and ESA website. JAXA seeks to create the outcome shown here with a researcher from the university and many institutions. As explained by Dirk-san, JAXA nicknamed the EarthCARE as Hakuryu. It's meaning the white dragon. Adding the reason for naming Hakuryu by explained Dirk-san, this year is symbolized dragon in Japan. Dragon year occur in every 12 years. Now, EarthCARE will be launched, and like dragon rising to the space, it will become an entity that envision the future of Earth. I have such expectation. Thank you.
Thank you very much to the JAXA team, to the project managers, to our speakers. And with this, we have plenty of time still left for any questions that might have come up during the presentation. So if any one of you has a question, please raise your hand and keep in mind that you will need to turn on your camera and your microphone because you need to accept that you are recorded. And with this, I would give the word to Marta Mili from Italy. Marta, the floor is yours.
Good afternoon, everybody. Thanks for your attention and your presentation. I've got a couple of questions, one for Maximilian Sauer and the other one for Simonetta Cheli. So I will start with Maximilian Sauer. I would like to know why it took so long to get from the kickoff to the launch, and how have you coped with the time going on and the technologies if you had to change the project during the 15 years that passed from the beginning to the end? And then a question for Simonetta Cheli, if you can tell us something more about how will it work, the receiving of the data from Frascati and the distribution of the data to the community, and what kind of data do you expect to receive at the end of 2024? Thanks for your attention.
I start. Okay. I mean, it's not, as said before, I think from one of the speakers, is a one-off, and is a cutting-edge technology. For example, the laser we have on board is something which has never been built in an ultraviolet area, let's say, a very special laser for space. We had a lot of technological issues, problems during the development. Lifetime, you need to show lifetime. We have, for example, the BBR on board, which is a rotating mechanism, rotates 10 million times during its lifetime, very quickly rotating. There are plenty of these kind of things which introduces issues you have to overcome, you have to solve, and you have to deal with. We had other things, external things like the Ukrainian war, the most recent one, which forced us to change launcher. It's not just to say I mount a satellite to another rocket. You have to adapt, you have to see how it works, you have to see whether the satellite survives the other environment which a new launcher provides to it. There was COVID, where we have to, during our development, handled cooperations with Japan and other subcontractors which were closed. All this introduced here and there months and even years to the project. However, we were able to cope with it. This is our job. We reduced teams, we adapted on certain levels, we focused on the most critical parts, handled it via I think good project management, so to keep the impact as low as possible, and to still resist on all these problems. And I think this is where we can be proud of. We were resilient against these issues, and in Europe able to build it. Other areas, other countries might have given even up and have not ever done this mission up to the point we are now. So it's more an achievement than a problem, I would say, that we are now here.
Thank you, Marta, also for your question. Me, just the role of Frascati is the role of the mission management, which is the role it has for all the Explorer mission, including for EarthCARE. So hopefully the launch will be end of May, as planned, as Dirk said. Then we have the initial satellite in orbit testing, and we have the initial products given to the Calval teams in terms of sometimes during the summer. Then we start after the summer the validation, calibration activities. Also, these are coordinated with the support of the ESRIN teams. And then the plan is currently to provide the first products to the users in 24, early 25. This will be done on a basis of a free and open data policy, which is the data policy of all the Earth observation mission with a mission management plan, which is currently foreseen for 3 years initial operations plus an option of 1. And this would be needed to be decided by member states in terms of a mission extension after the initial 3 years, which have been approved. And what will be done, basically the users, which are the scientists and the meteorologists, will use the data from EarthCARE to both improve the prediction of weather and air pollution, evaluate and improve the climate models, but also to explore the science basis of clouds and aerosols in climate change. So that's the main core of the work that will be done through the exploitation of those data from EarthCARE, which will be somehow coordinated by ESRIN with the entire international scientific community. And we had recently a workshop involving all the user community with strong interest and really very high expectation from the science community overall.
Thank you very much. We have another question from Jeff Faust.
Hello. This was touched on in an earlier question that Maximilian mentioned, but EarthCARE moved from Soyuz to Vega and now the Falcon, and I'm curious how that change affected design of the spacecraft, testing any sort of procedures to prepare the spacecraft for launch.
Maybe I can answer that. Basically, the design of the spacecraft, we managed to keep constant. So throughout the changes of the launchers, we did not have to change the design of the spacecraft. However, we managed to, during the test campaign of EarthCARE, we managed to adapt the environmental levels, the specific test conditions. We could adapt it to the different launches. And basically we tried to, and from the moment we knew that Soyuz was not available, we have been looking how stringent could we test the spacecraft to envelope other candidate launchers. And that's what we did, and that worked out in the end. The biggest differences were mainly the mechanical environment, vibration, acoustic environment, shock environment. These were the biggest topics we had to address, but luckily, and we really, this also shows the robustness of the spacecraft, we managed to stay with the design and not to have to introduce design changes.
Thank you very much. And then we have a question from Stephen Clark. Stephen?
Hello, everyone. I have 2 questions for you guys. First of all, do you have a total cost for EarthCARE, both from the ESA side and the JAXA side, to have an idea of the total commitment from both countries or both agencies? And also, could someone talk about, there have been aerosol cloud missions before. Most recently, I think PACE from NASA kind of has a similar mission purpose, mission objectives. How does EarthCARE differentiate from those previous missions? Thank you.
Thank you, Stephen. Maybe I could start on the cost on the ESA side. So EarthCARE total budget for space segment, ground segment, and launch service cost is of the order of 800 million euros. This corresponds to about 30% overall increase compared to the initial budget, and it's a higher budget than the average one of the Explorer mission due to the complexity of the mission, but also to what Dirk told us. I mean, the change of the launches, which happened, 3 times, the inflation, the war, so a number of complexities associated to the project, but also the size of the project. And this is the total cost for ESA, about 800 million euros. I will not comment on the JAXA part. I assume JAXA will respond on that question.
Okay, so regarding the JAXA budget, it's 8.3 billion yen. I think it's a rough estimation to the 52 million euro. Without NICT contribution and operation budget.
Okay, and then I can maybe answer on the question related to PACE. So indeed, there are other missions, and recently you mentioned PACE. The observation techniques are different. We have two active instruments, ATLET and CPR. They look really inside the clouds together with the combination with the other instruments. Now, we observe the same thing, but see slightly different aspects from the clouds and aerosols. And by the way, we are working together with the PACE team as ESA for the calibration and validation. So we are foreseeing activities that we have joint observations at the same moment, the same time with PACE and also with campaigns that we share data towards the PACE team, and the PACE team is using team data from us to compare the results, to calibrate and validate the results of both missions. So it's complementary, and we are working together with them.
Thank you very much. And with this, I would like to give the word to Christian Schwegal.
Hi, hello.
We hear you well.
Yeah, okay, great. I have a question for Simonetta, Cheli, and I'd like to continue the comparison with the United States. There was an article in the New York Times recently kind of warning about the forthcoming decommissioning of Terra, Aqua, and Aura. Is that a concern? And the warning was that there will be something like a blind spot in Earth observation. Is that only an American blind spot, or would it be like a global blind spot? So do you share that concern? And more generally, moving forward, as you described Europe as a sort of big power in Earth observation, what are there already kind of cornerstones for the next science Earth observation strategies you could share with us that are important in terms of what kind of missions will be developed?
Thank you, Christian, for your question. I have seen the article that you refer to. I think it's mostly related to a concern that is generally expressed in the US about potential budget cuts associated to the Earth's science budgets of NASA. In Europe, what I'd like to say, for the moment, we have quite good continuity and sizable Earth observation program. In fact, today, the European Earth Observation Program collectively with the MET mission, the Copernicus and the Explorer one, is the biggest in terms of infrastructure and also plans for the upcoming years in terms of data volumes and in terms of supporting the challenges related to sustainability, environment and climate. Of course, we have the next steps coming up, the ministerial meeting of ESA next year, where we'll have to guarantee continuity of those programs, also in terms of next satellites, next generation of Copernicus, for example, and funding associated to that, but also the next missions that we want to launch in the field of earth sciences. And there we have quite a number of missions which we need either to complete, like Harmony, which is a very relevant one associated to tectonics monitoring, oceanology, which should fly in complementarity with the Sentinel-1 and 1 next generation. But we also have future shortlisted Explorer mission. Dirk is in charge for those. Well, in the coming years, we have to guarantee continuity in terms of funding or confirmation in terms of funding. And we have a mission on gravity where we have, by the way, a collaboration on the science element with NASA, with Grace C, which is, currently planned on the NASA German side as a bilateral collaborative mission, and what we propose to the table of ministers next year, which is called NGGM, so a future gravity mission. So I hope there's no gap in supporting, I would say, what is needed in terms of data flow, volumes and type of data in the coming years. Certainly there, I think Europe is strong today. It should remain strong for the future. For the strategy, we are currently in the finalization of a science strategy. We started 2 years ago in ESA to work with the scientists in Europe to basically update the science strategy that was of 2015. We have done a science consultation with the wide science community 2 weeks ago to get feedback on the initial proposal. We are also consulting the advisory committee for the science, let's say, missions and objectives to ESA in 2 weeks. We are consolidating that science strategy, which basically has not only the ambition today and should be finalized, I would say, after the summertime, to have not just punctual missions associated to one single science objective, but a much wider remit of tackling science challenges. Today, we currently have 22 on the table for the science strategy as draft that should be more horizontal, and also science challenges that also should be connected more to policy priorities overall. That's currently where we are. We're in the middle of it, I would say, hopefully finalizing in a few months, but still in very active interaction with the science community in Europe for further consultation and consolidation.
Thank you.
Thank you very much. Are there any other questions? Any other comments? We have a few minutes left. No more questions, then I think we can close this media briefing. We have several opportunities, of course, leading up to the launch. As mentioned previously, launch is not earlier than the 28th of May. If you have any questions, any other comments, please contact us at media@esa.int, and I hope we will talk to all of you around launch as well. Thank you very much for joining us today. Have a good day. Thank you.
Goodbye.
Bye.
Goodbye, thank you.